In the last few classes, we have gone through the concept of semaphore, and there are three applications of semaphore. The first one is the critical section solution for n number of processes. The second application is to look for the order of execution for the processes, and the third application of semaphore is resource management. So about all those application related to the semaphore, we have seen in the last few classes. So there are two type of semaphore. One is called binary semaphore, which is also called mutex. Another is called integer semaphore, and which is your which will be used for your resource management. Okay, and so about that we have seen in the last class. Now in today's class, we'll discuss about some problems, and we'll try to solve some problem related to second application, which is called order of execution of the processes. That how we can define the order of execution of the different processes. Okay. So for that, I'll take a question. All of you can go with me. This is a problem related to process ordering using semaphore. Now the question is, suppose we need to synchronize two processes P and Q using two binary semaphore. S and T. So what is the question? The question is on process ordering, that how we can achieve process ordering using semaphore. In that, the question is, suppose we need to synchronize two processes P and Q using binary semaphore S and T. So we have two binary semaphore S and T. Binary means there is only two value, 0 and 1. But we have two semaphores, so S will have the value 0 and 1 and T will have the value 0 and 1. And we have the process P and Q that we need to synchronize. Now the question is on output of the string. So let's say what output I want. Output string should be 0 0 1 1 0 0 1 1 0 0 1 1. In that way, I need some output string. Okay. Now let's see what this process 1 and process P and process Q will do. So I'll write process P and we'll see what process P will do. Then I'll write process Q and we'll see what process Q will do. Okay. Now process 1 will go in a while loop and it will do a task W and it will print 0. and again it will print 0, and it will do some task X. In the same way, process Q will do some task Y and print 1. Again it will print 1, and it will do some task Z. So we have W, X, Y, and Z. These are some processes, some task that has to be done. And this is your process definition. Let's see what is W, X, Y, and Z. So we have W, X, Y, and Z. And we have, according to that, we have 4 options. Option A, B, C, and D. So this is your gate question. It comes around, I think, in gate 2011. Okay, so let's see. We have what W will do. It will do perform a function PS. X will do VS. Y will do PT, and Z will do VT. Next will be PS, VT, PT, and VS. Next is PS, VT, PT, and VS. Another one is PS, VS, PT, and VT. Okay. Let's see. In the first option, the initial value of S and T both have 1. In the second option, S will have the value 1 and T will have the value 0. The third option, S and T both have the value 1. Here we have the value of S 1 and T is equal to 0. Now this is the whole question. Now let's understand that what it want and how we can solve it. Now what it want is it want to use the concept of semaphore, and we have to solve, we have to pick any option A, B, C, or D. Means we have to pick up the value of W, X, Y, Z in such a way the output will be given like 0011 0011 0011, right? This should be our output. This is what is required, and we have to pick up any of the option. Either A is correct, B is correct, C is correct, or D is correct. And instead of W, X, Y, and Z, which was written in process P and process Q, we have to replace those W, X, Y, Z with the actual function. Now, what is P and what is V? We know a function in the semaphore called signal, right? What do you mean by signal? Signal here is V, and wait is P. So here P is nothing but wait and V is nothing but signal. So in signal, what will happen? We know that in signal we increase the value, and in wait we decrease the value. But in wait we have phenomena like we have to see another condition. The condition is we don't have to reduce it. First we have to see that whether the value is greater than 1 or not. If the value is not greater than 1, then we cannot perform wait operation, or we cannot reduce the value. In a signal, it doesn't have to do anything, it has to just increase the value. So about the wait and signal, we have seen in the semaphore, right? I don't have to go it again in the previous questions like this, and we don't have to look into that, right? Because what signal will do is it will just increase the value, whatever s value we'll give. And in the wait, what we have to do is we have to look for s value is greater than 0 or not. If s value is not greater than 0, it will go in a loop. If s value is greater than 0, then we have to decrement it, right? So the same thing we'll do here. Now let's try to solve this particular problem. So we'll solve the problem by putting the value of w, x, y, z instead of these empty places where w, x, and y, z are written. So let's take the first option, option A, and instead of w, what we'll write it? We'll write ps. Instead of x, we'll write vs. Instead of y, we'll write pt, and instead of z, we'll write vt. So I'll write one by one. Here we'll write ps, and then it will be vs. Here it will be pt, and here it will be vt. And what is the initial value of s and t? So value of s is 1, and value of t is also 1. Okay, let's see what will happen. So which particular process need to execute first? What p is? P stand for wait. Wait means we have to do 1 minus. So the first thing is ps, means s is 1, so we can do minus of 1 because the value of s is greater than 0, so we can make it minus 1, and we can go into the critical section. We can print 0 0, and then we can go out. And what is this? Vs means it will just make a signal, means it will increment the value of s by 1. So it will increment the value s by 1. So right now the value of s is 1. Now what? I have the option to go again in this particular, process P can execute here. So again, if it will execute, then again s will be become 0, and it will become 0 and 0. And at last it will become 1 once we'll get the signal. Let's say now Q want to execute, so we can do that by, it is again PT, P is for wait, V is for signal. Wait means it will decrement by seeing that the value should be greater than 0. So it is greater than 0, it is 1 actually. So I'll put the value of T somewhere here. So right now the value is 1, so definitely it will go there, and the value of 1 will be reduced to 0. Now it will do a print of 1 and 1, and then vt means it will make a signal, means increment the value of t by 1. Now we have the option either P can process or Q can process. So there is no restriction that which one will process. Let's say again Q want to execute, so it can execute, and it will just print 1 and 1, and then again it will become 0, and once it will be go out, it will become 1. So do we getting the pattern? Now here we can get this pattern, we can get this pattern, as well as we can get this pattern. It means that if I'll execute P, I can execute. After that, I want to execute Q, I can execute. Means if I'll execute P, it will become 0 0. If I'll execute Q, it will become 1 1. Again, if I'll execute P, I can execute, and then I'll execute. So this is possible with option A, but this is also possible with option A, right? Or if I'll start with Q, so it will become starting with 1 1. Or if I'll go again for Q, then it will be 1 1 again. Then I want to go to the P, it will be 0 0. Then if I'll go again to Q, it will be 1 1. In that way also can be possible. So many pattern is possible, by option A. And what it is saying that the output string should be, it should not be other than this, but we are getting other than that. So option A is eliminated. So we'll eliminate the option and we'll try to find out the best option or the appropriate answer from the options that we have. Now, first one, we have seen that many other pattern is also possible. Now let's go to the second option, option B. Now option B says that W value should be PS, X value should be VT, Y value should be PT, and Z value should be VS. So let's write it. PS, VT, here it is PT, here it is VS. Okay. Now what is the initial value of S? Initial value of S, it is already given here. It is 1, and initial value of T should be 0. Okay. Now let's start. Now because the initial value of S is 1, T is 0, and the first is P. P is for wait in both the processes. So definitely if I want to execute process Q, I cannot execute because the value of the semaphore is 0 now. And if it is 0, it will be in a busy wait. If I want to execute P, I used to have the semaphore S, and the value of semaphore S is 1. And because it is greater than 0, I can execute this. So there is a restriction to execute Q, but there is a signal, means there is a provision to execute P. So once I'll go and executing P, the first is PS. PS is for wait. Wait means it will decrement the value by 1 and it will become 0. After that I have to print. So what it will print? It will print 0 and 0. After that there is a VT. VT means there is a signal, but it will do a signal on T, not S. So T will be incremented by 1. Now if S value is 0 and T value is 1, so definitely P1 cannot be executed right now because for P it required S, and the value as S is not greater than 0. It is 0. So ultimately we have to execute Q, because for the Q the value of T is 1, which is greater than 0. It is required an essential condition for wait. So for wait, it will see the value of semaphore. If it is greater than 0, then only we can do a decrement on it and we can execute the critical section. So now the critical section is print. So we are going to print 1, 1. And at last we have VS. What is VS? V means signal. Signal to S means this S value should increment by 1. Now the same thing will happen here. It will be increment by 1, and now we have S value as 1, T value as 0. So definitely I cannot execute process Q, because for process Q there is a PT and T is a semaphore, but T value is less than 0. Sorry, is not greater than 0. So definitely it will be in a busy wait and it has to execute P. Now for P, the value of S is 1. It will come here and wait will see the semaphore value is greater than 0 or not. It is greater than 0. Then it will decrement it by 1 and you will execute the critical section and you will print 0 and 0. Now after that it will do VT. VT means signal to T. Signal to T means increment the value of T to 1. Now Q can execute, P cannot execute. Why? Because it will become 0. So now value of S is 0, value of T is 1. Definitely P cannot execute. Q has to be executed. If Q is executing, the value it will become 1. Again after the signal, this S value will become 1, and because of the weight it will become 0. So P is going to execute and the value will be 0 and 0 in that. So we are getting the pattern actually. So we are getting the pattern, and this is the only pattern that we are getting from the option. So the option B is correct option. This is how we can find it out the correct option. Now let's talk about another variation of it. So the question is same. What we have? We have the output string that is required. It says that output string should not be 0, 1 to the power of n and then 0, or 0, sorry, 1, 0 to the power of n and 1. So it says that output should not be this. And we have the same process. So we have process P, we have process Q. Okay, code is also the same. While 1, W, print 0, then again print 0, and then X, while 1, Y, print 1, again print 1, and Z. What are the options for W, X, Y, and Z? We have the option A, B, C, and D. Let's see, the first option is PS, VS, PT, and VT. Here S as well as T should be equal to 1. And the second option is PS, VT, PT, and VS. Here the value of S and T will be 1. Then the next option, we have PS, VS, PS, VS. Here only S value is 1. Then VS, VT, PS, and VT again. Here the S and T is 1. So these are the different options, right? We know that signal means V, and weight means P. So weight will decrement and signal will increment. So here we have the condition, the semaphore value should be greater than 0. Semaphore value should be greater than 0. So here we have two semaphore. What is that? So I'll write semaphore here. S and T. So let's try for the first option. So instead of W, I'll write PS. Instead of X, I'll write PS. For Y, I'll write PT. And for Z, I'll write VT. Only PS, Vs, Pt, and Vt. Okay. Now the value of S is 1 and value of T is also 1. Now, because the value of S and for the value of T both are 1, I can go to any of the process first. Let's say I'll start with P. So if I'll go to P, my S value is 1, which is greater than 0. So I'll decrement the value of S by 0, and I can print. Okay, before that, let's see what it want. It want that this pattern should not be there. So let's try to find out whether this pattern are there or not. Okay. So if you want to write the smallest pattern of this, so the smallest pattern will be 1. Okay, here also we have the n value. N value should be odd. It means that if we are using 0, so how many 1 should be there? Either 1 or 3 or 5 in that way. So smallest string, let's say we have only 1 1. So it will be 1 0 1 0. This is the first smallest string that is possible, and for that the smallest string is 1 0 1. So if I'll getting this or this from any of the option, I'll just eliminate those options because it says that it should not be. So if I'm getting this, it means I will just eliminate it. So what is my objective? Objective is to find out the options, and from the option, I want to find out these pattern. If I'm getting these pattern, means I'll eliminate that. So it is just to finding out the right answer by elimination. So let's see. We have the value of S and T as 1. Both are 1. Now, because both are 1, the first PS and here also we have PT. Both will be executing, means we can either execute P or Q. Both are possible. If both are possible, so let's execute P. If I am executing P, so process P, so it will do PS. PS means it will wait. Wait means it will decrement the value of S by 1. It will be 0. Then it will print, let's say 0. And after that, what should be the pattern? 1. Whether other pattern are possible? Let's say after that, there is a preemption. If there is a preemption, that what will happen? The queue want to execute. Preemption means queue want to execute. So P will save its state, and it says that I have executed up to this code, and after the resume, we can execute this code. So right now what has been printed? 0 has been printed. Right now Q want to execute. So once Q want to execute, it will come here. Can Q execute? Yes, Q can execute because T value is 1. Then it will reduce it to 0 and it will print 1. Let's say here there is a preemption. And now P want to execute. Can it can do? Yes, it can do because it is already in the critical section and we have allowed it to go to the critical section. And the next instruction is this one, which is a print 0. So we are just printing 0. Now we are getting the pattern. This pattern we are getting. It means that with the option 1, we are getting this pattern. It means that A will be eliminated. A cannot be the answer. Why? Because the question says that this pattern is not possible. But here we are getting this pattern, right? So this option is incorrect. Now let's go to other option. The second option is PSVT, PTVS. Okay. What is that? PS, then VT, then PT, and then VS. Here also we have S is equal to 1 and T equal to 1. Now here it is PSPT. Again, the same thing was there. So PS is there, right? So we can come here or we can come here. Means we can execute any of these once. Means the first time we can execute any of these. Let's say we are executing Q first. Let's say we are executing Q first. So when we execute Q first, the T value is greater than 0. Definitely it will be, the wait will be executed and the T value will be 0 and it is going to print 1. Let's say here we have a preemption because we want the pattern, right? So this we want, now I want 0. Is this possible? So because S value is 1, it is possible. This will become 0 and we can come here and we can print 0. After that, can it will be preemption? Yes, it can be preemption and it will execute from where it left. So from here it left, now it will execute and print 1. Yes, it is possible. So 0, 1, 0 is also possible, right? So this option is also incorrect. Now let's go to the third option. The third option says that it should be PSVS, then PSVS, PS, VS, and then PS and VS. And it is taking only one semaphore, that is S equal to 1. It is not taking another semaphore because all are S. Now the option we have is either we can go for P process or you can go to Q process. So any of the process we can go. Let's say we'll go for Q process first. So once we'll go to the Q process, the semaphore value is greater than 0. So it will execute. S will be decremented by 1. It will be 0. And then we can print 0. Now what I want 1. And I can do preemption here. Now, can we execute this process Q? Because I want the pattern 1. Once I'll come here, it will find out the value of S is already 0. It should be greater than 0. So Q cannot be executing. Why? Because wait will not allow it to execute and wait will go to the busy waiting. Because the S value is not greater than 0. It is 0 actually. So Q is not at all allowed. So definitely again once the control will go to the P, so we have to execute P and it will become 0, 0. And after that it will be VS. VS means signal on S. So now it will become 1. Now P also can execute, Q also can execute. So my pattern will either, if let's say P again want to execute, it can execute, it will become 0, 0. It will is was 0. Now after the signal it will be 1. Now if Q want to execute, it can execute and we have the output 1, 1 and then again it will become 1. So what I want to tell you is that 0, 1, 0 or 1, 0, 1 is not at all possible. Why? Because we have only one semaphore, and if we have only one semaphore, only one critical section could be allowed to go. Only one critical section could be allowed to go. So previously what was happening in one critical section, we can go to another processes critical section. But here what is happening is because we are using only one semaphore, it is strictly allowed to execute only one critical section at one time. So these type of pattern are possible. Means the 0 will be n times, means let's say it will be even times, and 1 will be even time, and this value of E will be either E will be even, right? So this type of pattern is possible. Either it will be 0 or any even value. Even means either it will be so it will be either 0, 0, 1, 1 or my pattern will be 0 0 0 0 or 1 1, or my pattern will be 1 1 1 1 0 0, or my pattern will be 1 1 0 0 0 0, in that way. So what pattern I'll get? I'll get 0 to the power of e, 1 to the power of e, and e will be either 0 or even value. Okay, so my answer will be C. C is the correct answer, where I'll not get this pattern, not at all get this particular pattern. So I think you understood the functionality of Semaphore for the application of process ordering. So if you want to do some sort of ordering between the processes, I can do this in that